There are 48 participants. We can wait for a few more minutes. Now there are 60 candidates. I think we can start now. Good evening, everybody. We are going to start the third session of our workshop. I am handing over this session to our beloved speaker, Professor Vishnu Ganguli.
Thank you, ma'am, and welcome to the today's session of Python programming workshop. I hope that you were able to understand the concepts that we discussed so far in last, I think, 2 days of the workshop, 2 or 3. This is the third day, I guess.
This is the third.
This is the third, yeah. So we have given a few basic things about Python programming, like how to define variables, how to assign values. After that, how to use some conditionals, how to use a for loop. These things we have seen, and in addition, we have seen something related to lists. And yesterday, we have seen in detail how to access elements in the list, how to modify some elements in the list, and how to create new lists from existing lists, which is known as list comprehension. These things we have seen. And now, today we are going to continue with list. I think we have almost all the basics have been already discussed. Now we need to introduce one more, in fact, three more, not one more, three more data types or data structures available in Python. One is known as a tuple, other is known as a set, other is known as a dictionary. These things are interrelated. And using these things, we will see some functions also. And in addition, we will try to see, we will continue with discussing loops, which is one construct for a loop is actually left, which is the while loop. We will discuss the while loop. And we will see some import using already defined, predefined functions in mathematics and non-mathematics available in Python. We will see how to make use of these functions. These are the main topics that we are thinking about discussing today. Okay, let me start sharing my screen. As yesterday, I will be using my Spider interface for writing the programs, and I will be copying and pasting the entire code, whatever I'm typing, to a Google document, the link of which I will share now. The link is here. Somebody is not muted. Can you please mute? I think the
Please mute.
Kritika, can you please
Kritika,
mute
please
yourself?
mute.
Thank you.
Please mute your phone.
Kritika, please, you mute your.
Hello.
Okay, thank you. So let us start a new program. I'm starting a new file. What name should I put? I think yesterday we went up to the 10th file, so I'm continuing with the numbering scheme, so that later I can share the entire file with you if required. So 11 double basics. So this is the name that we will keep. Let me save it with exactly the same name. So in Python, a tuple, tuple, whatever we want to call it, it is nothing but we have seen that in the case of mathematics, whenever we are doing something in mathematics, there are many occasions in which we want to use ordered pair and the generalization of that two tuple, and after that three, after that n tuple. All these things we may have to handle in the case of mathematics. So it is nothing but a sequence of numbers arranged in some particular order. Okay, the ordering is very important there. In the case of list also, the ordering is very important. So the triple and list share many common features, but there are certain differences between triple and list. Okay, triple is highly restricted compared to list. I will explain what exactly I mean by that. Let me start defining a triple. It's very easy. I'm just using my triple instead of that. I'm using empty as the word. So 1, 3, 5. That's it. So this is how we define a triple. Instead of square bracket, we have to use ordinary bracket. Ordinary that parenthesis we have to use. And if we ask to print this empty, sorry, if we ask to print empty, and if we ask to print the type of empty, so this type of command is very useful while trying with your programs. This is actually a very useful command, very useful feature available in Python, so that you can see that what exactly the name of whatever you are defining in Python is running. So you can see that this is a triple 135. Now we can access individual elements in the triple in the following way: print empty. So exactly as in the case of a list. Sorry, exactly as in the case of a list, you need to use square brackets. That's one. 1 to 2. Okay, 1 to 2 is not going to work because 1 to 2 simply means that one alone. 1 to 2 will work, but only one will be shown. Now, just as in the case of a list, you can do this also. Now, as in the case of a list, you can try the length command also. No problem. That also works. Length of the triple is maybe I can close this and tell it afterwards. It's 3. That's also there. Okay, these things are almost the same. There is no difference between a list and triple. Let me update the Google Sheet. Google Sheet is now updated with this column. But now the differences start here. Okay, let me define a list also in the same way. ML, my list, square bracket. So printing type elements, two things I'm trying to print. Formatting. Uh, in format, I am asking for type of ML, which is a list, and ML itself. Running. So this is a list. Elements are 135. Empty. Empty. Elements are 135. It's a tuple. Now, what is the difference? ML. Suppose that I want to change the first element in my list, which is 1, to 1.5 or to 2, say. ML 0 equal to 2. New list is ML. So 235 it has become, works perfectly. Let me try to do exactly the same thing with MG. MT0 is equal to 2. There is an error message which says that object does not support item assignment, which means that MT0 you cannot change, MT1 you cannot change, MT2 you cannot change. But instead of that, you can completely change MT altogether. So item wise assignment is not possible. So that means that once you define a list to be this, either you need to change the end. Once you define a tuple like this, either you need to change the entire tuple, or you just keep it like that. So in some way, the right side of this empty, which is 135, this is a constant. You cannot change individual things. You cannot change. So 135, you need to keep it as 135. Otherwise, you can completely change it. MT0, MT1, MT2, even though you can access these elements, you cannot change it. You can access, but you cannot change. That's the difference. Okay. So MT2, you can define it to consists of strings also, element, another. This is also possible. Print MT2. Oh, sorry. This I need to suppress. Following is wrong. I'm suppressing even this. Running. So element another is strong. Now, can I take an element from this? EL equal to MT 2 0. What is EL? Element. So that's possible. Now, what is MT 0 0? MT 0 0 is E. Everything else works perfectly. The only difference is that the only difference between a tuple and list is that you cannot modify individual items in a tuple. Okay, so this is actually desirable provided that suppose that sometimes we may want to define some coordinates. So when you are changing the coordinate, you may not want to change only one particular coordinate. You are changing because coordinate actually corresponds to one point. If you are changing the point, the entire tuple is going to change. So in such situations, when you do not want to modify the inside elements without modifying the entire thing, you should use the tuple class for defining an element. Okay, let me update. That's the basic difference between these two. Otherwise, there is no difference at all. You cannot change items individually. Otherwise, tuple and list share exactly. And one more thing, of course, as you cannot change the items inside that, you cannot put any items also. Suppose that we try to append. Suppose that we try to append one more. Let us say again, tuple object has no attribute append. You cannot append also. So you cannot modify the list. You cannot modify the tuple on the right side. That's it. You have to, once you define it to be something on the right side, once you define MT to be equal to 135 or MT2 to be equal to element another, you cannot change individual items. You cannot simply put anything into that. You cannot delete also. can try to delete also. This is wrong. Trying to delete. Delete the zeroth element. Will it work? Let's see. Object doesn't support item deletion. So this is also wrong. Okay, all these things are wrong. So modifying the tuple is not going to work. That's it. So this is also wrong. Updated the Google document. You may try with this. Of course, you can define, you can mix up elements in the list, in a list, just as in the case of a list, you can mix up elements in a tuple also. You can put a numerical value as well as non-numeric value inside a tuple. But as I told yesterday itself, that most of the times it's not going to make much sense. Mixing up of data types inside that. Okay, that's the other data type that we have. You may try with all these things. And just remember that. And one more thing is that you can actually convert from a tuple to list. You can actually convert. So already you have seen that empty is here. Now empty ML or list from empty. I'm just giving a variable name like that. So just use the list command. And when type of this, and value of this also running. So this is a list. So can we use the can we go the other way also? That means creating tuple from list, tuple from ML equal to type of this, and what is this? Okay, that also works. Both these things are okay. Okay, so we can convert from a list to a tuple and tuple from list. Both these things are possible. Conversions. Let me update the Google document. I have updated. You may try now. Okay. Now let us move to the other data type. And the next data type is known as a set. As usual, set is nothing but it's actually a mathematical object. It's a kind of mathematical object. We have been using sets in all our mathematics related definitions, operations, etc. So Python also offers a data type called a class data type or class, whatever, called set, which has almost all the features that a usual set in mathematics has. So let us go to a new program defining a set and seeing how to make use of it. So as the 12th program, we will try to define sets. So defining set is really easy. The usual structure of defining a set we may have to use. Suppose that we define, let us see it in action, how to define a set. So let us define a set A equal to. Suppose that we want to define, okay, instead of, I will directly type A is equal to 1, 2, 3, 4, 5, 6, 7, 8. Suppose that I define like this. So you have to use, we have to use a set like bracket here, curly braces for defining a set. Now B equal to, suppose that I define B to be elements from 5 to 15, but instead of defining it directly, I can, what do you call, use the command, use the keyword set. And but now what should I do? Let us try to define it as a range from 5 to 15 I want, therefore 16 let us take. Let us try to see what are these elements, whether these definitions are correct or not. Print A, and maybe B also we will print simultaneously. Let's see. So A is 1 to 8 and B is 5 to 15. Perfect. So this is how we define set. In curly braces, just include all these elements. Now one more interesting thing. C equal to 1, 2, 3, 1, 4, 5. We know a basic feature of set. What is that? Duplication of elements will not actually appear finally in that set. So one element will be appearing only once. So let us see if that property is holding in the case of Python sets also. See that 1, 2, 3, 1, 4, 5 is the number of is the elements in C, are the elements in C. But on the other hand, when we are trying to print 1, 2, 3, 4, 5 is appearing. That means the duplicate one is now filtered. This can be actually, this property can be actually made use of for filtering duplicate elements in a list. For example, suppose that filtering duplicates in a list. So how do we do that? Suppose that we have a list, ML, my list equal to 1, 2, 3, 5, 1, 2, 5, 10, 20, 30, 20. Suppose that we have these many elements. Okay. Now, how do we filter the duplicates? Print or ML, no duplicates equal to, we need that as a list again. So let us convert that first. So now all the duplicates are gone, but now this is set. We don't want a set, we want a list. Convert it back, print it. So 1, 2, 3, 5, 10, 20, 30. Let me update the Google Sheet with this. Updated. So maybe we can even include one more line here. And If you want to find out distinct number of elements, you can count. Format this and count. That's it. Oh, sorry. Count. Or, oh, sorry, count is not exactly the thing. Count is actually for counting elements inside a list. Sorry, this is length. Sorry, I made a wrong statement. Yeah. So a distinct number of elements is 7. So this line is also updated in the Google document. This is a very useful property. It's a very useful behavior of sets that we can filter out duplicates if there are any. But some important things to remember about set is that you cannot access elements item wise. So this is not going to work. Print A 0. Set object is not subscriptable. Subscript is 0. This is not allowed. So this is wrong. Now what next? Can we try to? So we cannot access it like that. So how do we delete an element? Can we delete by some value? Remember that in a set, one value will be appearing exactly once. So let us try to remove. A dot remove a value. With A. So removed. So remove command is working. Delete cannot work because delete is working on subscript. Subscript we cannot use here. What about append? A dot append 1. Will it work? Append is not going to work. Can you add? So this will not work. Can you add an element? A equal to. Let us add 1 to it. Will it work? Let us try to see after. So here by addition, what we mean is list addition. When we are adding to list, what happens is that the list gets appended. Will this work? No, that's also not working. But we know that in the case of a set, instead of adding, we usually take something called union, right? So A equal to A union. So A dot union. Remember that we have used a dot, and inside the bracket there is a set. After union, 1, 2, 3. Oh, that's perfectly well. And can take any union. A union C. A union C. A union C is 1, 2, 3, 4. What is our C? Oh, you should probably take B because C is a subset of that. A union B, that works. What about the intersection? Not A union C, this is A union B. A intersection B works. Now, what about this? Will it work? That's also working, A and B. But in that case, A or B also should work. A union B, that's working. What about A minus B? Will it work? A minus B simply means that remove all the elements in B from A. Yes, that's working. Now, what about this operation? Oh, sorry. What is this? This is symmetric difference. Okay. So this is nothing but A union B. Sorry, A minus B union B minus A. A minus B union B minus A. So these are the basic operations that are supported in the case of sets. So I have updated the Google document. You may try. Now there is one more. A or C is subset A is C is or is C A subset of A and answer. So the answer here at the place of the first bracket C should appear, second bracket A should appear, third bracket C is subset A should appear. So what will be the final outcome? Oh, we have given only two brackets. Subset of here, yeah. So is 1, 2, 3, 4, 5 a subset of 1, 2, 3, 4, 5, 6, 7, 8? True. That's the answer. So is subset of superset. So in that case, you should reverse. Or if you ask this question, you will get the answer to be false because you need to reverse. You need to reverse A, C, A, C. Updated the Google document with this. Let me try. And of course, you can find maximum minimum of a set also. But this maximum minimum is going to work in the case of list, set, triple, everything. Maximum of is. So we need to format. A need to print maximum of it. That's it. So maximum of 1, 2, 3, 4, 5, 6, 7, 8 is 8. And minimum is, and minimum is 1. So how do we find the arithmetic mean? Just take the elements in A, take the sum of elements in A, take the number of elements in A. See this sum of a, maximum of a, minimum, maximum, minimum, sum, length, all these things will work for list as well as triple as well. So this is not specific to set. Since we haven't introduced this maximum, minimum, sum, these things in the case of list, I'm just saying this. This will work everywhere. Updated the Google Sheet, Google document. Now let us do a problem of finding the greatest common divisor using this sets. That's very easy. So finding GCD using sets, that's a problem. So open a new file. This is 13 GCD using sets. So how do we do that? Suppose that we want to find the GCD of two positive integers. So how do we find the GCD? By the definition of GCD. Remember that GCD is nothing but from the very word GCD, very phrase, short name, whatever, acronym, whatever. So it is the greatest common divisor. So we need to find out divisors. Okay. So given two integers A and B, we need to find out the divisors of A, divisors of B. Then we need to take so set of divisors of A and B we need to form. After that, we need to find the common divisors, then take the greatest. So it's as simple as it is. So let us ask for input, and we want integer because we want to find GCD. So A is the integer we are asking for. Just like that, we can ask for B also, another integer. So what is next? We need to form the set of divisors of A. Let us call it as div. So remember that we are assuming, of course, that A and B are both positive. We are leaving it for the user to give A and B such that they are positive. Otherwise, we may have to write some extra line to verify if A and B are positive or not. Okay, so I'm not going to that part. I'm just assuming that A and B are given by the user is positive. So how do we find the devices of A? How do we check? How do we find out all the devices of A? Any technique for that? Any idea for that? How do we find the devices of A? Any idea? Any suggestion from anyone?
So we can use one loop, right? And we can keep dividing this number up to that number,
So you want to use you want to use a loop, right?
right?
Okay.
This
So
completion,
yeah, that's actually a very good idea. In fact, that is the only thing we can try because there is no other way to find out devices as of now. We don't know any other method to find devices as of now. So instead of using a separate loop, we can use the loop inside the list itself. List comprehension can be actually made use of because we don't have to write a separate loop for that. So let us use loop inside the list to get the devices. So we need D from where to where we have to try. Remember that the greatest divisor of A is going to be the greatest divisor of A is going to be how much? It's A itself, right? A itself is a divisor definitely. So up to A we have to divide definitely therefore, right? So up to A we have to divide. So we need to take the range from 1 to A and check if something is dividing A or not. So D should come from 1 to A and D must be dividing A. That's a condition that we have to use. Okay, so D for D in which range? 1 to not A because if we use only up to A, the problem is that A itself will not be covered. A in this range, if what is the condition that we should put on this D? D must divide A. So A percentage D must be equal to 0. That's it. Okay, let us try to see that if this code is correct or not. After that, we will suppress it. So I'm suppressing this B also. Let us try to see the divisors of 20, for example. So I'm trying to see the divisors of 20 and 1, 2, 4, 5, 10, 20. Perfect, right? So it works. So in the same way, we can find out the divisors of B also. So D for D in range B plus 1, B. I'm just giving the name of the set as divisors of a div A, div B. So printing is not necessary. We can take. So now we need common divisors. Common divisors. How do we find? See here we have actually made use of a list comprehension. But the problem with using list comprehension is that you cannot take intersection of two lists. Okay, cannot take intersection of two lists. We can take intersection of two sets. So you need to convert this into sets. Set div A dot intersection set. We are converting inline conversion directly at the same point we are converting. We do not write a separate line for that. There itself we can convert. So divisors of A is a list now. Convert that to set. Take intersection with divisors of B is also a list. Convert that to set. Take the intersection of these two. Let us see that also in action. Maybe we can use same statement of maybe here itself we can put all these things using F divisors of A are div A of B are div B common divisors are common div. That's it. So this print is not required. This print is not required. Let us see if it's working. So A, as in the case of I'm putting 20, B 50. So divisors of 20, 1, 2, 4, 5, 10, 20, 50, 1, 2, 5, 10, 25, 50. Common divisors are 1, 2. See that? These two are given as sets. Sorry, lists. This is also a list. But here, this is a set. And what is GCD now? GCD is. What should we do now? Or GCD of is. In that case, we need F here. Formatting string is. Oh, but here the problem is that, okay, let us try to find out maximum here itself. Maximum of common div. Let us see if it's working. Once again, 20, 50, 10. Perfect. So this program finds the GCD of A and B using the direct definition. This is a direct definition. This is the definition of GCD. Let me update the Google Sheet with this program. Done. May copy, paste, and try. I'm pausing for a minute so that you can try this, you can have a look at this. And after this, we will move to using while loop for finding the GCD much more efficiently. Using the famous Euclidean algorithm for finding the GCD. Is there any question?
Yes, sir. Excuse me, sir. That is inside the print. Entry F is there. What is this F stands for?
F stands for, see, here we have kept A inside this curly braces, right?
Okay.
And B also inside this curly braces. Once you put this F, Python will interpret this curly brace to be formatted. The content inside the curly brace to be formatted.
Okay.
So instead of printing A, the value of A will be printed at the place of curly brace A.
Okay.
Yeah. So this is equivalent to, this particular format is actually equivalent to typing GCD of A, empty bracket. So this is equivalent to A, B, is equivalent to this.
Yeah. Okay.
This is a short notation or a little bit more easier to understand notation, because in the second notation, what happens is that all the values are appearing towards the end.
Yeah.
So you need to make a correspondence between one and one. So first one corresponds to this, second one corresponds to this. So you may get confused and you may make mistakes also. So
Okay.
this one is the latest. I think the latest formatting command is this.
Oh. Thank you, sir. Thank you.
Okay. Equivalent. I have added this comment also equivalent to the Google Sheet. Okay, that's it. So now, as I told, we are going to see how to make use of the while loop, and we will see through a program. So, in fact, using the while loop. Okay, let us see the while loop in action first, and after that, we will try to use it in the program. So, using while loop it's quite straightforward. It is just like the for loop. The only condition is that we are not specifying any range there. Okay, let us see some small program using while loop. So our 14 program. So the structure of while loop is very easy, very simple. Suppose that we initialize, or what you call,
Iteration.
okay, that's a keyword there. Okay, I will put the variable name to be this. Suppose that we want to perform the iteration 10 times. So remember that we know that we can put 4, 1 to 10. Exactly the same thing can be achieved in while also. But the thing is that some extra things may be required. So while iteration is positive. So 1 to 10 we want. So just see that what we are trying to do. Or otherwise, the better word is probably countdown. Since we are bringing it downwards here. So while countdown is greater than 0, so print countdown. Maybe here itself we will print. Okay, so didn't I save? Okay, let me save it. So what's happening here is that initially the countdown variable is assigned the value 10. So while countdown is greater than 0, so initially the value is 10, therefore countdown greater than 0 is true. Therefore the value of countdown variable, which is 10, will be printed. After that, countdown will become countdown minus 1. That means that 1 will be subtracted from countdown, so it will become 9. Still it is greater than 0, therefore again the value of countdown will be printed. That's it. Go on like that. Let's see. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 0 was not printed because the countdown will take place only if it's greater than 0. Otherwise, you should put greater than or equal to. If you put greater than or equal to 10, 9, 8, 7, 1, 0. So that's it. So here the structure of this while loop is you need to specify a condition here, inside bracket or not inside bracket, doesn't matter. And after that, put a column, just as in the case of a for loop, if condition, else condition. Now do something, and you need to take care that this condition must be made false inside the loop. Okay, otherwise it will result into an infinite loop. So suppose that you are writing countdown greater than or equal to 0. Suppose that you are not reducing countdown by any number. What will happen is that countdown will always remain positive. So the loop will never terminate. It will become an infinite loop. So the condition to break the loop must be given inside this while loop. So this is actually useful when you do not exactly know that how many times you may have to execute something. Okay, but in this particular case, this while loop is not actually what do you call much intuitive or much sensible to use, because we don't know exactly that we need to count from 10 to 0. So the number of countings required is 11. That's clear to us. So in such a situation, we need to actually use for loop. So the next example will actually tell us that where do we need to use while loop instead of for loop. Okay, the next example. Let me update the Google Sheet with this example anyway. Updated the Google Sheet. starting a new program, finding the GCD using while loop. Remember that we have already found GCD using direct method of finding the set of all devices, taking the set of all common devices, finding the maximum of that. That is actually the definition. Now we are going to make use of the Euclidean algorithm. Using as I told previously that if you want to make the computer or Python interpreter do something, we should clearly know that how exactly to do that thing. So if we do not know how to actually do some calculation, we may not be able to tell Python compiler to Python interpreter to do exactly what to exactly do. So in that case, the very first thing is that we should understand exactly what we want to do. Okay. After that only we will be able to tell Python interpreter that what we exactly need. So let us try to understand the Euclidean algorithm first. So the very basis of Euclidean algorithm is that given a and b two positive integers, or in fact in the theory of Euclidean algorithm, you want at least one of them to be positive integer. Then only you will be able to find the GCD. Of course, one of them is non-zero is enough because GCD of negative number also can be found. But since GCD of negative number as well as GCD of positive number there is no difference, we can assume that one of them at least is positive. The other one can be, in fact, zero. A be positive. Suppose that B is smaller. One of them is definitely going to be smaller. So the first step is that we have to write B is smaller. So write divide A with B, write the quotient, find the quotient and remainder. B, Q plus R. So what is the next step in the Euclidean algorithm? Next step in the Euclidean algorithm is in the place of B, write this remainder. Suppose we write this as Q1, this as R1. Now in the second step, we will write B equal to, so take in the place of B we have R1. So in the place of Q1 we have some Q2, we don't know exactly what it is, R2. What is the next step? Keep on doing like this. In the place of B we should bring this step. So B replaced with R1. Now R1 goes to the left side. So the operation is this. So A, B, R1. These are the initially A and B are the initial elements. We are finding R1. After that, in the position of A, B is appearing. So B is pushed to the position of A. Now what happens to the position of B? To the position of B, this remainder is put. Okay. So this is the change happening inside this loop. So to the position of A, B is coming, and to the position of B, remainder is coming. Here, to the position of B, R1 is coming, to the position of R1, remainder is coming. That's the iterating step, right? That's a looping step. So here, R1, R2, some other Q3, R3. So we will continue this process until the GCD, the remainder becomes equal to 0. Once the remainder, suppose that this R3 is 0. In that case, the last non-zero remainder is R2 and R2 is the GCD. That's logic. But what is R2? R2 is actually the remainder. R2 is nothing but the remainder obtained on dividing B with R1. Therefore, R2 is nothing but according to our notation. So this R1 is nothing but according to our notation. This is A percentage B. Okay. This is nothing but B Q1 plus A percentage B. So every time the remainder is A percentage B. A percentage B is now pushed to B. Now The last step, what happens is that this is 0. Okay, the remainder is this. This is stored in which variable? Just suppose that A and B are two positions in the computer memory. So to A, we are always pushing B. To B, we are always pushing the remainder. So in the last step, inside B, the last remainder will be remaining. Last remainder is 0. But in A, what is remaining? The remainder before that is remaining, which is the last non-zero remainder. So the GCD will be finally in A. The GCD will be finally appearing in the variable A. Okay, let us see that in action. And after that, if you're unable to understand that logic, I will try to explain much simpler. So we are asking for A and B, or otherwise we can straight away put A and B from here. Suppose we put 2072, some number I'm choosing, Y. What we need to check? We need to check the remainder all the times. So remainder is A divided with B, A percentage B. So even before that, we need to check one more thing, that if A percentage B itself is 0, if the remainder is 0 in the first step itself, the GCD is equal to, what is GCD? If A percentage B is equal to 0, that means that B divides A. If B divides A, the GCD is going to be B itself. Okay. A percentage B equal to 0, then GCD is B itself. So let us print it. A percentage B equal to 0. Simply print GCD is B itself. Because for example, see that 2000 and 1000, suppose that A and B are 2000 and 1000. So 1000 divides 2000. So in that case, the GCD is going to be just equal to 1000. No need to check. A percentage B not equal to 0. We are going to try something, we are going to do something. So what is the step? So we need to push to A, we need to bring the value of B. To B, we need to bring the value of B percentage A. So to AB, we need to bring B comma B percentage A. So the meaning of this statement is, to A, put the value of B, and put to B, put the value of B percentage. If you want, you can see it in action. Print A equal to BQ plus R. So how do we find this? A, B. Now what is Q? What is our Q? How do we find Q? Q is what? Q is the quotient. So for finding the quotient, use the floor function. Floor function. I don't know whether you need to use math library for that. Okay, I'm skipping that for the time being. For the time being, I'm skipping that. Instead of that, print A, B, A percentage B. Not equal to. Okay, that should come close. And finally, the GCD will be in A because B has become already 0. Last remainder has become 0. Then only we will come out of that. Okay, this possibility also I am just suppressing for the time being to avoid some confusion. Okay, let us see in action. What is wrong here? A percentage B not equal to 0. A has become B. B has become, oh, sorry, A percentage B. So these are the steps. So in the first step, we will get 2072 equal to 1072 into something plus 1000. Second step, we will get 1072 plus 1000 into 1072 equal to 1000 into 1 plus 72. Third step, we will get 1000 equal to 72 into some number plus 64. Fourth step, we will get 72 equal to 64 into some number plus 8. In the last step, we will get 64 equal to 8 into 8 plus 0. So 64 equal to the last. Sorry, one more minute. The GCD is there for 64. Is that correct? I guess so. Try to see that. 2072 by 64. Will it divide? No. GCD is therefore stored in where something is wrong. What exactly we should do? A percentage B is pushed to B. A percentage B not equal to 0. Uh, so let us see the steps once again. 2072 equal to 1072 plus 1000. So in the first step, A percentage B is 1000 not equal to 0. So all these things are executed. Second step, 1072 equal to 1000 into 72 is is a remainder executed again. So 72 is assigned here also. 72 equal to 64 into 8. Okay, instead of A percentage B, okay, so here this is not actually becoming 0. So B is not getting the value 0 because before that it's getting the loop is breaking. Therefore, GCD is in B, not in A. The final one is in B. Okay, that's correct. Maybe I can write one more step here. One more way to explain it properly. A equal to Q I cannot find because I need to use another function which I have not explained how to use that. B Q plus R for my B, A percentage B. That's it. So the GCD is so here we have to definitely use while loop because we don't know exactly how many times the loop is going to run. Okay, there is no way for us to understand how many times this loop is going to run. Therefore, we cannot use for loop here efficiently. Of course, we can use for loop, but making for loop work in this particular situation is going to be much more difficult compared to using a while loop. So here, this is better. While loop is better. Let me update the Google document with this. Update. You may try these commands if it's working in your system, your Colab interface if you're trying with Colab. Please remember that the spacing after the spacing just before the print inside by loop and a comma b equal to b comma a percentage p, that indentation needs to be maintained properly. Okay. So, is there any question related to this while loop, this GCD problem? I can try to clarify if there is any. Okay. So let us move to a new topic. Before going to a new topic, I think one more data type is actually left to be introduced. That is dictionary. Dictionary, I think for small programs, it's not going to be that much required. But the thing is that if you are many of the objects inside the Python programming language is defined using dictionaries. So we will just try to give you I'll just try to give you an example in which this dictionary is going to be how to define and how to use dictionary. I will tell. I'm not going into details of dictionary. If we require, if we need to use the dictionary at one particular time, we will definitely make use of, and we will define. We will use programs like that. So let us try to define dictionary before going to new concepts. So this program is 16 dictionary example. So dictionary is defined exactly in the same way as that of a set, but the difference is that a dictionary and list are exactly the same. So dictionary and list they share not exactly the same. They share several common features. Okay, but in the case of dictionary, in the case of list, we know that we are accessing the items by specifying their index, where the indices are non-negative integer values starting from zero. But in the case of dictionary, what we have to do is that we have to define our own indices like this. Something like this. Uh, math 80. Suppose that we are defining a dictionary consisting of marks of certain subjects. Physics 79 something. So remember that we are using a colon, not semicolon, colon. You can keep on doing like this. So the indices we have to define. Now statistics, suppose it's highly scoring. So this is how we define a dictionary. Now how do we access them? Just using the index math phys stat like that. So MD square bracket max. That's it. So instead of using MD0, we have to use MD max. That's the only thing. Oh, math. Sorry. Marks for mathematics is 80. So this is a very simple example, and you can define a bit more complex things also. Maybe I will write I can define a dictionary inside dictionary. Math 80 like this. Now for 82, 75, 82, something like this. So this is a dictionary in which again dictionaries are appearing as elements. This is quite possible. This is possible. No problem. MD large. So dictionary invalid syntax. Okay. Here's something extra. So now Reshmi itself is this is an item index, and if you use MD large Reshmi, you will be seeing all the marks of Reshmi. I'm updating the Google document with this. Update. Please try. So this is a very simple example of dictionary where we can. So this is. I would like to just introduce the structure of dictionary so that when we are seeing some library functions, when we are seeing some advanced things in Python, some notations are appearing in the dictionary format. So we should know that how do they look like. The definition is more or less like that of a set, but the features are more or less like that of a list, not like set. Okay. So that's it about list. Now we will see some more programs. We will actually try to see how to use mathematics functions from Python libraries. So the next topic is to import libraries from the Python, import functions from already existing Python libraries. So we will start importing the math library first of all. New function starting. Importing functions. So most of the trigonometric functions, a logarithm function, the exponential function, in fact, not exponential function, we can take it to be the value of e itself. And functions like absolute value function, square root, all this power function, etc. Power function, I don't, yeah. All these functions are available in library called math library. So if you want to make use of all the functions available in the math library, you can import the math library completely to your program using import command. So now how do we make use of, so what are the things available in this library? We don't know, first of all. Maybe we can print the contents in this library. Let's see that first. So these are the available functions in the math library. So a cos, so this is a hyperbolic, cosine, inverse, ceiling function, I don't know what this comb is, cos function, degree function, distance function, distance. That also I have not tried. You can try to use that. So e is there, exponential function is also there, e is a constant. Factorial function is there, floor is there. There are several functions. Is finite, is close, is infinity, is not existing. NaN, not NaN, not a number, is nan, not a number. E square root, I think E square root, L gamma, all these functions are available. So you can see them using print dir math command. The pi is also there, product is there, radiance is there. Okay, let us try to make use of it here. Print. But how do we access these functions? So pi is a constant, e is also a constant. To access constants from that, we need to use math dot that function name or math dot that constant name. Print math dot pi. Value of pi is this. Value of is sine 90 degrees. Is. So how do we get that? Let me try with that. Math dot sine I need to use probably degrees, or I need to convert it into radians. Let us see that. Is it degree or degrees? Sine 90 degrees is a minus 0 point, therefore this is not degrees. So I need to convert this into radian. 90 is in degrees, convert this into radians. So 1.0. Sine inverse 1. You are getting this in terms of radians. So if you want to convert, now it's in degrees. Log E. Log is 1. I'm updating the Google document with all these functions. Update. Now the square root is also there. There is one small problem that the square root function is not going to work on negative numbers. So math domain error will be there. So you cannot use a square root function on negative numbers. If you want to use a square root function on negative numbers, or if you want to find the square root of a negative number, you need to import another library called complex math library and use square root from there, from CMath. This is not working. Domain error will be there. Square root of -4 is 2j. From this, you can actually understand one more thing. We actually expected, I think, 2i, but here it's appearing as 2j because in Python, due to some reason, I don't know why exactly it's like that. Maybe there are some historical reasons for that. Square root of -1 is represented by the letter j, not I, but j. And if you want to see the functions available in CMath, you can once again try this. Almost all the functions, but with complex argument. Polar, phase, these things are also there in addition. Updated the Google document. If you want, you can try yourself with the functions. And if you want help on some specific item, I think you can directly use print help. I think this should work is what I think. Let us try. Yeah, it's working. So the help starts from where? It's too large. The help is very large, very big. Maybe some small thing we should take. This is better. Square root z. You can find the square root of even a complex number. 2 plus 3i, 3j in the Python sense. And one important thing is that you should not Uh, Simply try to use j, square root of j. This will not work. Or square of j. This will not work because j will be treated as a variable which is not defined. So instead of, if you want to use j, you should use 1j, and to avoid ambiguity, use this bracket also. So this is represented as minus 1 plus 0j because it's a complex number. Because we are in the complex domain. So minus 1 plus 0j is the value given. I have updated the Google document with this. Okay, now let us see one program in action using these functions. Let us try to find the okay. Try to solve a quadratic equation. I think I had been contacted by one of the participants about a program for finding the roots of a quadratic equation using the square root function. Let us see it in action. It's a very simple program, straightforward. There is no complexity at all. Let's try to see this in action, just to see that. So let us 18 quadratic equation solution. So we are assuming that the equation is in the form ax square plus bx plus c. This is the form. So we require a, b, and c. A equal to, say, to start with, maybe we can take so x plus 2 into x plus 3. So 1, b equal to, so if we take x plus 2 into x plus 3, or x plus 2 into x minus 3 if we take, or x minus, okay. Uh, so the sum is going to be x minus 3, x plus 2. So minus 1, c equal to minus 6. Okay, so these are the coefficients that we are taking. Now we need to find the discriminant, which is square root of b square minus 4ac. But square root thing the problem now is that if you are using the square root of b square minus 4ac, if you are using the square root function from math domain, the math library, the discriminant can be negative. Therefore, it may create a math domain error. So safe to use the square root library from the CMath square root function from the CMath library. But instead of writing cmath.sqrt all the times, we can use a simpler command if we want only one function from CMath import sqrt, so that we can use sqrt straight away. Instead of using cmath.sqrt, we can use sqrt. So let us put d is equal to square root of b square minus 4 star. Remember that we cannot write 4ac. Instead of that, we need to multiply 4 star a star c, square root of this. Now, what are the roots? Of course, depending on maybe even discriminant is, I think, b square minus 4ac only. By conventionally, we call b square minus 4ac to be the discriminant, and square root of that we take later. So maybe even we can give some information also to the user that there are multiple roots, or there is only a single root. All these things we can tell. If d equal to 0, we can print only one root. We need to print only one root. Single or only one distinct root, and that is how do you find that? So we need to just take minus b by 2a. That's it. Minus b by, once again, remember to put 2 star a. And 2 star a, remember to put in inside the bracket, because otherwise we don't know whether this will be interpreted as minus b by 2 into a or minus b by 2a. We don't exactly know. So it's better to do like this. Else. So otherwise there are two roots. The roots are so what are the roots? Minus b. We can put this once again inside a bracket, plus square root of d again in the bracket by 2a. That is one value. And the other value is minus b minus this. That's the other value. So is there a mistake? Format minus b square root of d, that is inside a bracket, by 2a. After that, minus b square root of d inside again a bracket, 2a. Why is this a mistake here? Invalid syntax. Oh, one bracket is missing. Let's run that. Suppose that instead of that we change the equation to x minus 2 the whole square, or x minus 1 the whole square even. So in that case, this is 1. This is 2. is 1, only one distinct root, which is minus 1. This is x square plus 1. Sorry, x square, x minus 1 the whole square. This is x minus 1 the whole square. Let me update the Google document with this. I have updated the Google document with this code. Please try. So this is a very simple program for checking, finding the roots of a quadratic equation. Now let us try to find out one more. Try to do one more program in involving mathematics logic. So this is actually to find out the sequence of Fibonacci numbers. So the sequence of Fibonacci numbers we actually know. There is nothing new in that, provided that we have already understood the logic of creating loops and appending elements to a list. There is nothing new in this, but still, to make the ideas much more clear, let us try to do one more program. So we will try to create a Fibonacci list, a sequence of Fibonacci numbers using while loop. So 19, Fibonacci sequence of numbers. Let's try to create. So we know the definition of Fibonacci numbers, right? We know the definition of Fibonacci numbers is that start with the numbers 1 and 1. After that, keep on adding the previous two numbers to get the new number. Means if you have A1 and A2 or F1 and F2, then F3 is F1 plus F2, F4 is F3 plus F2, F5 is F4 plus F3, and go on like that. Definition is F1 equal to 1, F2 equal to 1, and F3 onwards, which suppose we call it to be F5 equal to F of I minus 1 plus F of I minus 2. For I equal to 3, 4, etc. This is the definition that we have. So let us start the Fibonacci sequence initially. Suppose we call that list to be Fibonacci list, Fibo list. Define the initial two elements to be 1, 1. So how many elements we want to find out? Suppose that we want to find the first 20 elements. So we need to keep on appending elements to this Fibonacci list until the length of the Fibonacci list is less than 20. That's the logic. So while length of bracket is not necessary, but I usually put brackets after this while loop so that to make the idea much more clear. Somehow I'm being used to putting brackets like this after while loop, after for loop, after if, everything. While the length of Fibonacci list is less than 20, we will do this process. But what is the process? So what do we need to add? Fibo list. What should we add? We add the sum of previous two elements. Let us try to find the L to be the list of this list for compact notation. Fibonacci list. Append. What is it we have to append? Fibo list. So what are the last two elements in the list? L minus 1 and L minus 2. So these are the two elements appended. We need to be careful about the indentation. Okay, fine. If the list is 20, what will happen is that when 20 elements are already there in the Fibonacci list, it will be broken. While loop will not continue anymore. So just print. First, how many numbers are, how many, and Fibo list. That's it. Very simple. So first 20 numbers are 1, 1, 2, 3, 5, 8, 13, 21, etc. That's it. Now, if you want to find the ratio of consecutive Fibonacci numbers, that also can be actually achieved. That is actually an interesting problem in mathematics itself. Let us take the ratios as an empty list. So ratio of what? Let us append the ratio of consecutive Fibonacci numbers. Means L is not going to exist by L minus 2. And see the ratio. That's actually an interesting thing to see. You see that? The ratio is starting from the third to second. So when we are finding out the ratio, actually three elements have been created. 1, 1, 2. So we are starting with the third to second. So if we look at the third to second from the ratio from third 3 by 2, third element by second element. After that, what happens is that the ratio is becoming 1.66, 1.6, 1.61, 1.61, 1.618, 1.618. So if you approximate, this is becoming around 1.6183, like that. This number is known as the golden ratio. The limit of these numbers is known as the golden ratio. Okay, you may have already heard about that. Maybe you can search for this thing in the Google, what exactly is golden ratio. And we can find out from this exercise that uh, by experiment, we can see that the ratio of initial numbers in the Fibonacci list is actually it's around 1.618, and it in fact converges to that number. That's an irrational number, not a rational number. That's an irrational number, and I think it's a transcendental number also. So that's a very famous number. Just try to find out the history, the story behind the golden ratio. Okay, and that's it only for today. Probably I will stop with this. Let me update the Google document with this. After that, if there are any clarifications required, any questions, you may please ask now. I have already posted the. Yeah, there is one question, please. Yeah.
Sir, we can import like a LaTeX code to this Python.
Letter code for what?
This for Python, any LaTeX code for Python, like so if in LaTeX we can we are using many code like to create some ratios like that. So the same code we can use in Python.
So in LaTeX, what we are using for creating ratios?
Not like that. It's creating some formula.
See, Python is actually a programming language which can evaluate formulas. So if you are asking about creating LaTeX code, if you have any specific example, if you can give me some specific example, I can try to answer. Otherwise, Python is a programming language which can evaluate, and of course we can create some symbolic expressions also. But creating LaTeX code in Python, I don't think it's possible. But maybe if you want to specifically know something, you can just try to find out some example and tell me. I can try to find out.
No, sir. But what I mean is this in Python we can import some math function like this import math like that. So the same way can we import like Python sorry like that.
No, LaTeX code cannot be imported to Python
Okay.
because LaTeX code is just a symbolic code where we are. If you want to import if what you are saying is you are typing an equation or expression in LaTeX, you want to make use of that directly in Python.
Yeah.
No, that's not possible. You have to write. You have to type things in the Python format itself.
Okay.
Otherwise, it won't be accepted.
Yeah. Thanks.
Anyone else?
So feedback link I have already posted to YouTube also.
We have successfully completed our third session of this program. I thank you, Professor Vishnu Nambudiri, for taking so much effort to make this workshop a successful one. I also thank each participant.
Yeah, in fact, what I want to say is, if the participants are asking some questions, then I will be able to explore more. Because otherwise, the problem is that I will be telling whatever I am familiar with, and there may be certain things which I may know, but sometimes I forgot to tell that thing. So if somebody is asking questions, I will be able to better clarify. That's what I think. So come up with your questions. There is no problem in asking any of these questions. If I don't know anything, if I don't know something, then I will try to clarify in the next day. There is no problem in asking at all. Thinking that what I feel, if I do not know the answer, there is no problem at all. You can ask questions. I will try to clarify either today or on the next day. Okay.
Also, asking question is a motivation to the research.
Exactly. Yeah.
Okay.
Yeah. Thank you very much.
Tomorrow's session will be at 6 p.m. Please join at before 6 p.m.
Yeah, Google document I have already shared. Okay, let me just share that link once again. I had already shared that thing, so I will share that once again to this chat box. Document link is here. All the code is pasted there, up to here. Okay, we will meet tomorrow. Okay, thank you.
Thank you.